everyone. Today I'd like to talk about something very important related to outdoor insulators, which is the non-intrusive inspection of outdoor insulators. So to start with, as an introduction, outdoor insulators are extremely important to the power system. They mechanically hold the overhead lines, as you can see here, and electrically insulate those conductors which are at high voltage from the tower which is at ground potential. Now, the cost of those outdoor insulators is only 5% of the total cost of the overhead lines. However, 50 to 60% of the failures that happens on overhead lines are caused by outdoor insulator failures. Now, the failure of outdoor insulators, you can classify them broadly as two main classes. Electrical failure, when there is a flashover that happened on the insulator surface, which will lead to line to ground fault, which might trip your protection system, or mechanical failure that can happen as well. And you can see here, this is an example of a failure of non-ceramic insulators at 400 kV, and though this is a bundle of four conductor overhead lines that is actually fall on the ground. So these are very serious consequences happens whenever there is a failure of the insulators, either electrical failure or mechanical failure. So it's very important to inspect the insulators to make sure that they are safe from these failures. The first category of inspection methods, we call them intrusive methods. In the intrusive methods, you have to go there, and either you need to shut down the high voltage lines, which is intrusive in that aspect by actually cutting down the power, or you have to go there personally when the line is energized and do some inspection. Here, for example, the workers, they are trying to measure the voltage across the string of the insulators to figure out if there is any damage in those insulators. So it's very obvious that intrusive methods are both not safe and extremely expensive because they are not efficient. You have to do one insulator at a time. You can imagine the time it takes the workers to climb on the towers and make sure that they are with a safe distance from the high voltage lines, and doing the inspection for every single insulator one by one. The other category of inspection, which is non-intrusive. Non-intrusive in the sense that you do not need to shut down the line, and also you are not in a physical contact with the high voltage lines. You use certain types of sensors that you can have with a safe distance from the conductors. As you can see here, this is basically an RF antenna, and this is an outdoor insulators. We are doing the inspection of any damages using the RF antenna. So you do not shut down the line, and you are safe with respect to your location with the insulator. Now, there are, as I mentioned, the failures can be classified as electrical and mechanical, but they stem from some faults that happens in the insulator, and they escalate until we have a complete failure. So for example, for the mechanical failure, these are some cracks that will actually trigger some discharges, and if these insulators are not inspected at an early stage, they might get broken, and then mechanically the whole line might fail. On the other hand, you could have polluted surface. So in the polluted surface, this can lead to some discharge on the surface, and that can lead to the complete electrical failure of the insulator. So there are certain non-intrusive inspection methods that are used, and they can be classified into two main categories. The first one is called vision-based, using regular camera, IR camera, or ultraviolet camera. On the other hand, there is another category of inspection methods. They are based on the field that is emitted from those types of faults, and we use for that acoustic or ultrasonic sensors and an RF antenna. So let's talk about a specific fault. This is just an example of one of the faults, which is the dry band arcing. Now, I will not talk about dry band arcing because I have one complete video. I will leave the description of that video in the course description in the video description. Okay, but let's look here to the dry band arcing. This is a short video, shows the dry band arcing. So now, whenever there is a dry band arcing, there is a heat. So you can use the IR camera. There is sound coming from the dry band arcing, then you can use ultrasonic sensor. And there is a radiation of electromagnetic waves, both low and high frequency. So the high frequency can be detected by the RF antenna. So this physical fault, dry band arcing, that can lead to complete failure of the insulators can be inspected using these three methods. Now, please join me. I have one demonstration in the lab that shows that specific fault, which is dry band arcing, and we can see that how we can use these three sensors to detect those three or to detect dry band arcing in different ways based on the sensor that we are using.
This is the setup that will be now testing. This is basically polymeric insulators. It's wet, okay, and it's connected to a high voltage transformer. So basically now we will energize this insulator, and we will try to measure the dry band arcing using three different sensors: the IR camera, RF antenna, and ultrasonic sensor. Now you can start to hear the dry band arcing on the surface of the insulator. Now we'll go and see it on the IR camera. See here the arcing now can be easily detected because it will increase the temperature. And you can see it here on the surface. Whenever there is an arc here, the temperature will increase. And this is how you can detect dry band arcing using the IR camera. Now here we detect dry band arcing using the ultrasonic sensor. So here the sensor will have its horn antenna here and connected to the sensor. When you look here clearly, you can see this detection of these ultrasonic sounds, very clear, very intense. Now we will just point the horn antenna far away from the detection. You can look here now, it went away because this is very directional sensor. It can only detect when you are pointing towards the source of the arcing. And this is one of the advantages of the ultrasonic sensors. Now we will try to detect the dry band arcing using an RF antenna. So this is the antenna here. And you can see here clearly that we are detecting, but now we are detecting only the high frequency components that is available on the dry band arcing.